Hey, third grade. In today's lesson, I'm going to teach you how to identify a function rule for an input and output table. Here I have an input-output table. In an input table, I'm going to put numbers into a function or into a formula, and then by using that, I'll be able to figure out what are my numbers in my output. So I'll call this left side the input, the numbers I'm putting into the rule here, into the function rule, and then the output would be the numbers I get after I do put the number into the function rule, and then what do I get out of it? That is called the output. Alright, so I look here, and the first thing that I see is that my numbers for A, the two numbers I do know, for A are less, 1 is less than 2, 2 is less than 4. So when I'm doing this, I know that my numbers have to be getting bigger, and the only way to get them bigger is by either adding or multiplying. Now if I was adding, the difference between these two would be the exact same every single time. The difference between 1 and 2 is 1. The difference between 2 and 4 is 2 though. So I can't be adding. I actually have to be multiplying for this one. Okay, so how do I get from 1 to 2? The only way to get from 1 to 2 is to take it times 2. If I do 1 times 2, I get 2. So let's try that for 2 and see if that works. If it works, then we've figured out the rule. 2 times 2 is 4. Okay. So then if I want to figure out when A is 3, what would B be? Well, I should do A, and in this case it's 3, times 2. 3 times 2 is 3 times 2 is 6. 3 times 2 is 6. And then this would be called my function rule. So I could write any number I wanted in A. Let's say I wrote down a 5 here. And I could use this rule, put this 5 in for the A, and do 5 times 2, and then B will be 10. I could put the number 20 in column A, and if I did 20 times 2, well, 0 times 2 is 0, and 2 times 2 is 4. B would be 40. So any number I put into A, B is going to be 2 times greater than that. Let's try the next one. So for A, I'm taking a look. As my number goes from here to here, it gets bigger. Here to here, it gets bigger. Here to here, it gets bigger. So I have to be either adding or multiplying. Now if I look here, the difference here is 3. Difference here is 3. Difference here is 3. So I'm probably adding. So if I do 1 plus 3, that's 4. If I do 2 plus 3, that's 5. If I do 3 plus 3, that is 6. So my rule here is whatever A is, add 3, and that will tell you what B is. This is my rule. A plus 3 equals B. So if 4 is A, well, I can do 4 plus 3, and that would be 7. What if I did, let's say, 8? Let's put an 8 there. Well, 8 plus 3 equals 11. Could do 12. Let's try a 12 in A, and 12 plus 3, that would be 15. Okay, so I can put any number I want in A once I know the rule, and I can figure out what B is. Let's try this one. I have E and F. Here is my, remember, input. Number I'm putting in. The number that I'm getting out is called the output. Okay, so as I go from this number to this number, it is getting bigger, it's increasing. I go from this number to this number, it is increasing. If I take a look here, so when they are all increasing as we go from the input to the output, we know adding or multiplying. Well, if I try to add to get from 1 to 5, I know that that's a difference of 4. If I go from 2 to 10, that's a difference of 8. If I go from 3 to 15, that's a difference of 12. It doesn't work to add. So this one is actually a multiplying rule. So let's see if we can figure out what the rule is. Okay, so whatever E is times, what would make this true? 1 times what is 5? Well, 1 times 5 is 5. Let's try that and see if that's correct. So if we take E times 5, it will tell us what F is. 1 times 5 is 5. That's true. 2 times 5. Well, that's true. That's 10. 3 times 5 is 15. So that's true. So it works for all three of those. 4 times 5. 4 times 5. That would be 20. If E is 8, well, all we have to do is take 8 times 5. And then that would be 40. Okay? So when I get to this part here, it's asking what is my rule? Well, over here, this is E. To figure out what F is, E times 5. That's what I would write there. Okay, so you'll see that on your homework when it says just an E here. What is the rule? Well, the rule is E times 5. Okay. This is a different kind of input-output table because as we go from G, the input, to the output H, we go down. We're actually decreasing. We're getting smaller. So from 5, we're going down to 3. Going down from 7 to 5. Well, are we going down by the same amount every single time, or are we possibly dividing into equal groups? So because we're going down each time, our options are subtracting or dividing. Okay? So we know what G is, and we know what H is here. So go from 4 to 2, I could take away 2, or I could divide by 2. So it could be 4 minus 2, or it could be 4 divided by 2, and that would get us here. So we have to take a look at the next one so we can figure out what the rule is. 5 minus 2, well, that equals 3. But if I do 5 divided by 2, that does not work to get us to 3. So we know that it can't be divided by. So it actually has to be whatever G is, take away 2, and we will get H. And if I do 7 minus 2, that equals 5. So I've done 3 of these, so I know that that has to be the rule. It's the only one that makes sense. So then for 8, well, we'll put an 8 right here. 8 minus 2, H would be 6. Let's put a 15 in for G. 15 minus 2, that would be 13. And our rule is G whatever G is, G minus 2. Two more examples to go through here. Okay, so let's take a look at J and K. As I go from the input J to the output K, are my numbers getting bigger or smaller? 2 to 14, 3 to 21, 6 to 42. That doesn't, I could be adding, or I could be multiplying, but the difference here is very, very different. The numbers are getting further and further apart. So I know that it's probably not adding. I am probably multiplying. Well, what number could I multiply times 2 to get to 14? I'm going to think a little bit. 2 times what number is 14? Well, 2 times 7 I know is 14. 3 times 7. Does that equal 21? Yes, it does. Okay, 6 times 7. 6 times 7? Yeah, that equals 42. So my rule here is J, whatever J is, take it times 7, and then you will get the letter K, what the letter K equals. 7 times 7, we're doing this one here, 7 times 7, what would that be? That would be 49. 10 times 7, that would be 70. Okay. And then my rule again is J times 7. Alright, this one I have an input-output table, but it's not going vertical, it's going horizontal, and it doesn't change how this works at all. So this is still the input on top here, and this is the output here. So it can be written either vertically, going up and down, or horizontally going from left to right. As I go from the input to the output, the 3 sets that I know, all of the numbers are getting bigger as we go from R to S. So we have to either be adding or multiplying. Okay? Well, how do you get from 2 to 7? I can't multiply a number to get from 2 to 7, so I know that it's probably not multiplication. But if I add 2 plus 5, I can get to 7. If I add 5 plus 5, I get to 10. And if I add 9 plus 5, I get to 14. So I know my rule should be R plus 5. R plus 5, that will tell us the letter S. Well, what's 7 plus 5? 7 plus 5 is 12. If you notice, our numbers do not have to be in order for this table to work. Okay, I went 2, 5, 9, 7, 11, and then 20. They don't have to be in a repeating pattern. We just need to figure out what is the rule, and then apply that rule to whatever number R is. So R is 11 this time. So 11 plus 5 is 16. And 20 plus 5 would be 25. So that's another one of my favorite lessons this year, because you really have to think and you really have to understand numbers and adding and subtracting and multiplying and dividing to be able to figure these out. So we're taking all of these things that we've learned all year long, and we're taking them and we're putting them into a much harder concept. So if this was hard for you today, please ask me questions. Kids do struggle with this at first, but after they practice a few of them, it gets a lot better for them. So Please try these. Hopefully they're not too overwhelming, and if you do have questions, please ask. Good luck finding the rules to function tables. We'll see you next time, third grade.